Hello everyone. In this video, I am going to cover two fundamental searching algorithm or the way to search the data into our data set. One is linear search and other is binary search. Let's start with the linear search. So this is the simplest technique where we check each element in a list one by one until we find the target value or we reach the end of our list or data set. So let's start with the linear search. I will take a sample array, let's say some random elements. So our array has six elements and index, as you know, the index start with 0 for array. So 0, 1, 2, 3, 4, and 5. So let's say we need to find a element with value 1. So our target value is 1. So 1 is at fourth index. So if we need to find if we are using a linear search, then we will start with the first element of the array and compare it with the target value. So we take the first value, that is 3, and we compare with the target, that is 1. Again, we pick the next value 8 and compare with the target value. We pick 4, next we pick 9, and when we reach here, there is a match. So we found 1 at index 4. So this is how a linear search works. And let's start with a binary search. So the prerequisite of binary search is that our array should be sorted. So let's create another array. Let's say 1, 2, 5, 6, 7, and 9. Okay. Again, we have 5 elements. Let's say this time our target is value 6, which is at index 3. So how you are going to do it? So basically what binary search do is like it reduce the array to the half repeatedly until we find the match. So with every run we reduce the array to half and compare the middle value with the our target value. Okay, so this is a way of doing or implementing a binary search. So the first and foremost thing is to find the middle element of the array. So we will start with how we can find a middle index so that we can find the middle element. So middle index will be, so I would say it's a left side and this is a right side. So our left side index is starting with a 0 and right side is 5. We need to find the mid value. So we say, so the formula is like left plus right minus left and divided by 2. So basically we are uh, dividing our array into two halves. So I will prepare a table here so that you can have a good look about the values. So let's say middle index is M. I will denote left with L and right with R. Okay. So this is I'm going to. So initially left is 0 and rightmost index is 5. So we feed this data into the formula and we get 0 plus 5 minus 0 divided by 2. So the value will be equal to, this will come to 2. So middle is 2. Let's pick the value at index 2. So the value of at index 2 is 5. Now what? We need to compare if, let's say our array name is ARR and we found just the index, I will still say mid equal to target. If there is a match, we return the index. We are returning an index. So let's go through it. So the array mid is 5, our target is 6. So this condition doesn't fulfill. Else, so what is going to be the next condition here? Else if, now what if our value is less than target? Okay, the middle value is less than target. Let's see the array. So this value is less than target. Then what we need to do is we need to update the left side. So we will say left equals to mid plus 1 because the value must be on the right hand side. So we need to shift the left index. Okay. So we will move left index to plus 1. Let's iterate again. Now our left side is 3, right side is still 5. Let's calculate again what is the mid value. So mid value will be 3, 5 minus 3 here and divided by 2. Okay. And plus the left side. So this will give you the, so this will come 3 plus 1, it will be 4. Okay. So now the value is 4. Let's iterate again. Now your value at index 4 is, it's 7. So we are here. Now let's execute our conditions again. Obviously this is not equal. So we are not here. We move to the else part. Array mid is less than target. This is also false. So we need another condition where array mid is greater than target. So this is the scenario we are handling right now because fourth element is 7 and target is 6. So now the case is we need to modify our right side. So what is going to be our right side now or right index? So right will be equals to mid minus 1 because now this is our original array and our target is less than our mid value. So we need to move to the left side. Okay. So we need to adjust the left index now. So the initial value of, so here the mid value was 4. 4 minus 1 is, it is 3. So this is 3. This is still 3. Let's calculate the mid value again. So it is left, that is 3 plus left, right minus left divided by 2. It comes out to be 3. So everything is like middle, left and right all are 3 now. So let's see like what is at the third index. Oh, so on third index, we have our target value. So again, we will check if the middle value is equal to target. Yes, we found our target value. So this is how the binary search works. And for like this is almost like all the part of the pseudocode. Just you need to add the condition here, a while loop, which says left is less than equal to your right side. I will write the pseudocode again here. So while your left index is less than equal to your right one, okay, you first calculate the mid value. Mid equals to left plus right minus left divided by 2 if array your mid value equals to target, okay, you return the index. So in this case, this is mid. So it says you found the element. Else, if your array mid is less than target, we need to search to the right half. So we will shift the left index and search right half. Else, if array mid, so we don't have to explicitly write this condition, but just to make it clear, I am just putting it here, and we just need to adjust the right side if this is the case. So it says search left side. Okay. And if somehow you don't find the element, you just return -1 out of that function. So this is the complete pseudocode. Hope you understand well like how uh, we are calculating or we are finding our target value using the binary search. So binary search is beneficial when we have a large sorted data set and we need to find a element again and again or a repetitive task of finding the elements. And linear search mostly wanna work on a smaller unsorted data set. So let's quickly understand what is the time complexity here. So as in this case, we have to uh, search like on the whole array. So the complexity will become as order of n. And in case of binary search, because we are reducing the array to half from its original size, So on each step, we are reducing to half. So the complexity will be log of n. Okay. So these are the complexity for linear and binary search. Let's start with some code. So I will be using Visual Studio Code here, and I will be doing the code in Java. So there is a sample Java class here, linear binary search, what I name it. Let's create some functions here. I will start with creating a linear search function here. So let's write, and the return value is integer type, and I'm expecting a array as an input. So this is an array, and the second parameter will be a target. So its code is very simple. We just need to iterate, int I equal to 0 and I is less than whatever the length of this array, and I plus plus, and this is a one condition here, just one. If array I equal to your target value, you are done. So just return the index. And if you don't, let's make it more clear and specific. And if you don't find any element or your target value, we simply return -1. Okay. So let's start like how you can use it. So we have an array. Let's initialize with some value 1, comma 4, comma 7, comma 9, comma 11, 13, and let's have a target value, let's say 11. Okay. Now I will collect the return value. Index equals to, I will call this method. This is linear search, and I need to pass an array and my target. Okay. So if index, I would say not equals to -1, this means we find our value. Okay. So we say value found at index. Let's print the index. Else, can I have another value not found? Okay. Let's run. Hmm. So we found the value at index 4. Let's see, 0, 1, 2, 3, 4. So this is the fourth index and we found the value. Let's run where we don't have any value. Let's say 10. Our target is 10. Let's rerun again. Okay. So it says value not found at index. So it is returning our the error code, that is -1, if we don't find any value in our data set. Now let's write a code for binary search. So we again need this, and I will just rename it to binary search. Okay. And we will write, like I already covered the pseudocode, so you just need to convert in a code. So we have in left index equal to 0, and we have in right, this will be equal to the array length -1, because array length for element 6 it will return 6, but the index is always 1 less. Now we have our while loop, so it says left is less than equal to right. We start with calculating our middle index here, or starting to divide the array. So we need to first find the index. So and our first condition, if array mid equal to our target, we are done. Then we are going to return the index. Now the next part, else if array mid is less than the target, then we need to adjust the left index, and we need to move forward so that we will look our element into the right side of the array. Else we need to adjust the right, because this means our element is on the left side. Um, we again return -1 if we don't find the value. Let's do it. And let's binary search. I will replace with the binary search here, but this should be sorted. So I will write is, oh, it is somehow sorted. Very nice. 1, 4, 7, 9, 11, 13. Okay, so let's run it. So again, 10 is not the part of our array, so it says value not found. And let's say we give a value 13. Now it says value find at index 5. So this is code for linear and binary search in Java. Hope you like the video. Thank you.